Okay, hello and welcome to video 3. This is the third video in Unit 6. Unit 6 is radical functions, and today we're focusing on operations on radicals. So what that means is we're adding, subtracting, multiplying, and dividing radicals. So before we really get into it, we're going to take a moment and define some things. Make sure we're all on the same page in terms of terms that we might be talking about. So this little guy out here, this little guy out here, that's in that little nook of the radical symbol, this is called the index. You might remember back in video number 2, the index tells us how many we have to have in each group of the same term in order to pull it outside the radical. So in this case, for this square root of the fifth root of 3x, we would need things in groups of 5. Now this 3x, everything that's underneath the radical, this is referred to as the radicand. So that just is the stuff under the radical. So in this case, it's 3x. So just like in Algebra 1, when you talk about like terms are the things that you can combine, like add or subtract. In radicals, we also have like terms. What's considered like terms for radicals is that they have the same index and they have the same radicand. If both things are there, if they have the same index and the same radicand, then you can combine them. If both of them are not the same, then you cannot combine them. Both of them have to be there in order to combine them. So let's get into adding and subtracting then. So there are two major steps in adding and subtracting radicals. The first one is to simplify all radical expressions. So simplify, that was what you learned how to do in video number 2, where you pulled things out of the radical, left some things in the inside, grouped things together, that sort of stuff. If you're not completely sure about that yet, you should go back to video number 2 and practice it some more. Make sure you learn it well, or ask your teacher some questions, go in for extra help. Now, that's the first step, simplify. So we'll be doing a little bit, but other than that, I'm going to assume that you know how to simplify, and then we'll go from there. The second step, after you simplify radical expressions, then you just add or subtract like expressions. Remember, like expressions, in terms, if you're talking about radicals and you're talking about like expressions, we need the same index and we need the same radicand. And then other things like numbers, if they're just numbers, there are no radicals attached, you can combine them. Same rules apply. Now let's look at example 1. So take a moment, scan it, and see how many like terms there are. Okay, how many like terms are there? Well, there are 2. There's this 3 square root of 5 and this 10 square root of 5. How do I know that they're like terms? Well, there's a square root of 5, there's a square root, so they're both square roots, and then under the square root, there's only a 5, so they're the same. The index and the radicand are the same, so we can combine them. So if I have 3 square roots of 5, so let's just say I have three square roots of 5 just hanging out, and then I have 10 more, then total, I have 13 square roots of 5. Okay, so those two combine to get 13. The 3 plus the 10 gives me 13. And then take another look and see whether there are any other like terms. There's a negative 5 square root of 2, and there's a 4. Are they like terms? No. So what we're going to do is we're just going to bring them down, bring them along for the ride. So we have a negative 5 square root of 2, and then we have this plus 4. And then that's it. So that one was just to kind of dip our toes in. Now we're going to have to do some simplifying. So I'm going to do 1 for simplifying, and then I'm going to assume, I'll show you all the steps for simplifying one of them, and then from there I'm going to assume that you know how to simplify radicals because you should have learned it in video 2. Now, this 7, we don't need to simplify, so we'll just bring it down. Now let's take a look at this negative square root of 72. So we have a square root of 72, and we need to break it down. So it breaks down into 9 and 8, for example. There are other options, but I'm just going to break it down to 9 and 8. Now 9 can still be broken down more, and we can break it down into 3 and 3. Now 8 can be broken down more, so we can break it down into 4 and 2. For example, there are other options, but I'm going to break it down to 4 and 2. Now 4 breaks down into 2 and 2. And can these 3's and 2's be broken down anymore? No, so we're just going to leave them. So they're the ends of the branches that we're going to look at. Now for this square root of 72, what is really the index? You can't see it, but what is it really? Well, it's a 2. So what that means is we need to group things in groups of 2 before we can pull them out. So I can group these two together. Remember, you can only group things that are the same. These 2's are the same, so we can group them. These 3's are the same, so we can group them as well. Remember what Miss Mills said in video 2? They're trying to escape out of jail, but everybody but one gets shot. So we have a 3, that moves on the outside, he makes it outside. This 2 makes it on the outside, and we're going to multiply these. And then there's this lone 2 that's hanging out by itself. Since it wasn't in a group, it has to stay in jail. So then square root of 72 simplifies to 6 square root of 2. So we're going to bring that back up here. So we have a minus, we'll bring that minus down. And then we have the 6 square root of 2. And the second one, when you simplify square root of 98, you could pause this video, take a moment, or you should pause this video, take a moment to simplify square root of 98, and then restart the video. Or don't restart it, just continue the video. So square root of 98 turns into, once you've simplified it, is 7 square root of 2. And then negative 4 square root of 2, that next term, well this one, the 2, nothing will be pulled out under the radical, so that's already simplified, so we'll just bring it down. So we have a minus 4 square root of 2, and then we also have this plus 4 at the end. Okay, so take a moment, scan it, see how many like terms you have, okay? So, how many did you count? Well, I counted 3. So there's this negative square root of 6 square root of 2, this positive 6 square root of 2, and this negative 4 square root of 2. These are like terms, so remember they're all square roots, so they have the same index, and then underneath the radical, it's all 2. So they are like terms, so we can combine them. So all we do is we add or subtract the numbers on the outside and bring the square root of 2 along for the ride. So negative 6 plus the 7 gives us 1. Negative 6 plus the 7 gives us 1. Then we subtract 4, and we get negative 3 square root of 2. So that's where this came from. These 3 things combined become the negative 3 square root of 2. Now take another moment and look and see if you can see any other like terms. Okay, I hope you said that there were still like terms, because there are. There's this 4 and there's this 7. They are just numbers. There are no radicals attached to them, so you can combine them. So we have a 7 plus 4, so we have an 11. So this 7 and this 4 become this 11, and our final answer is 11 minus 3 square root of 2. Remember, since 3 square root of 2 has a radical and 11 does not, they are not like terms, so we cannot combine them, so we'll just leave it as 11 minus 3 square root of 2. Okay, all right, so let's continue with the next one. How would I give you a moment? I'll give you a hint. These 3 radicals are not most simplified, so you can simplify them. So what that means is to put things in groups, pull them out, things like that. So why don't you take a moment and simplify those 3, and then we'll continue talking about it, okay? All right. Okay, well, welcome back. Let's see what it is when we simplify them, okay? So we have this 3. This 3 comes along for the ride, and then square root of 20x turns into 2 square root of 5x. Okay, then the next one we're subtracting, and we have 2, and then the cube root of 40x turns into 2 cube root of 5x. And then the last one we have a minus, and we have 2 things in the parentheses here, but the square root of 80x turns into 4 square root of 5x. And then we also have this plus 5 that's inside the radical. Okay, all right. Now, before we can continue, if you notice over here on the left, there's a minus, and then there are 2 terms inside the parentheses. Well, this is the case where we really have a negative 1, and we need to distribute this. So we have a negative 1 times the 4 square root of 5x. So that's going to make it negative 4 square root of 5x. And then we also have this negative 1 times this positive 5, which makes it minus 5. Okay, and then these other ones, we can we'll just multiply these numbers on the outside. So we have a 3 times a 2, and that's 6 square root of 5x. We're going to multiply this 2 by this 2. We have a minus 4 cube root of 5x. Okay? Take a moment, make sure you see what happened, and then now take another moment and determine whether you have like terms here. Okay, well, I hope you said yes, that there were like terms, because we have two. We have this 6 square root of 5x, and we have this negative 4 square root of 5x. We combine them, we have 6 minus, if we have 6 square roots of 5x, and then we take 4 away, like subtracting the 4 square root of 5x, then we end up with 2 square root of 5x. Now the other two that we have left, we have this negative 4 cubed root of 5x, and we have this negative 5. These are not like terms. Remember, one has a radical, one does not. They don't have the same index, they don't have the same radicand, so we can't combine them, so we'll just bring them along for the ride. So we have a negative 4 cubed root of 5x, and we have this minus 5, and that is our final answer. All right, so that is adding and subtracting radicals. You'll get lots of practice with this next day in class, so prepare yourself for fun times. All right, now second one, multiplying and dividing radicals. That's the second half of this lesson. All right, so the only time we can multiply and divide radicals is when the index is the same. So if you think back to the adding and subtracting that we just did, the only time we could add and subtract radicals were when the index and the radicand was the same. However, with multiplying and dividing radicals, it's a little bit different, and you can only multiply and divide when the index is the same. Now, the steps that you follow for this is, well, you first simplify all radical expressions. So do that first, and then you're just going to multiply. So what happens when you multiply? You have to multiply and divide in a very particular way. So the numbers that are outside of the radical, you're just going to multiply or divide those, and then they're going to continue to stay outside. They were outside before, and they will still stay outside. And then you'll still have the terms that are inside, the numbers and the terms that are inside. You'll multiply and divide those terms, and those inside ones, and they're going to stay inside. All right, so let's try some examples then, shall we? All right, so this first one. Well, actually, let's start with this guy down here. We'll start with number 6. All right, so number 6. All right, so again, this is a multiplication problem, so we're going to talk about the steps. We multiply the numbers that are on the outside, and they're going to stay outside. Then we're going to multiply the terms that are inside of the radical, and they're going to stay inside the radical. And then we're going to simplify. All right, so let's multiply. So we have this 5 that's outside. We have this negative 3 that's outside. We'll multiply those two, and we're going to get a negative 15. Okay. Now, we're going to multiply the terms inside the radical, and they're going to stay inside the radical. So we have a 3. We'll multiply with the other number here that's also a 3. So 3 times 3 is 9. So we get 9. Then we have an x, and there's no x there, so we'll just write the x down here. We have a y times a y cubed. Remember, when you're multiplying variables that are the same, you add the exponents. So this is y to the first, so we have 1 plus 3, so we have y to the fourth. And then lastly, we have z times z, which gives us z squared. And then we will simplify the radicals. So we have a negative 15 that just continues on for the ride. It's on the outside. This 9 simplifies to 3 and 3. And they both make it outside. We're going to multiply it with that 15. This x is not big enough to go in a group, so it stays inside. This y, we're going to have 4 y's. And we have to group them in groups of 2. So we end up with 2 groups of 2. So that'll be on the outside. Remember, everybody but 1 gets shot, so we have y squared. We have a y from here and a y from here. Together, they're y squared. And then we also have the z squared. We can group them in a group of 2, and then there's a z on the outside. And then we simplify, multiply the numbers you can. So whatever's left on the outside, you're going to multiply them, and then whatever's left on the inside, you're still going to multiply them. So negative 15 times 3 is negative 45. Then we have a y squared, and we have a z. And then inside the radical, we have an x. And then that's our final answer. Negative 45 y squared z times the square root of x. All right, so now that we have that one under our belt, let's try number 4. So we're doing things a little out of order, but I think you'll be okay. So this You have two terms in the first set of parentheses, two terms in the second set of parentheses. So what do? I'm looking for a four-letter word here. It is called FOIL. So we're going to do first, so we're going to do this 3. Oh, hold on one second. Let me move it down a little bit. So we multiply the 3 times the negative 4. So that's our first. First, 3 times negative 4. Maybe I'll write out all the steps. So we do a 3 times the negative 4. That's our first one. Second is O, so it's outer. 3 times the 6 square root of 5. So we have, remember it's a positive times a positive, so we have plus here. And we have a 3 times 6 square root of 5. Then we have an inner, the two inner ones. So we have a negative 4 times a negative 5 square root of 5. We have a negative times a negative, so that makes it a plus. And then we're going to do 5 square root of 5 times 4. And then we have last, which is this negative square root of 5 times 6 square root of 5. We have a negative times a positive, so that's a minus. And we have 5 square root of 5 times 6 square root of 5. All right, so let's put our multiplying into use. So we have 3 times negative 4. That will give us a negative 12. Then we have this guy here. We have two numbers that are on the outside. This 3 is a number on the outside, and that'll multiply with this other number on the outside, the 6, and we will get 18. And then we have the square root of 5 that comes along for the ride. The second one, similar things happen. We have a 5 that's on the outside, and we have a 4 that's outside. And remember, outside, I'm meaning outside the radical, so we're going to multiply those two and have 20, and then we bring the square root of 5 down for the ride. And then, the last part is a little more complicated, but it's okay. So we have a 5 and a 6 that are outside, and there's a minus. So we're going to multiply those. So 5 times 6 gives us 30. And then we have two things that are inside. We have this square root of 5. We have 5 under the radical. We have another 5 under the radical. So we have to multiply those two, and they're going to stay inside. So that'll be a 25. All right, so let's simplify this. I think square root of 25 is I think 25 is a perfect square. I think I know that that's an exact number. So you should know that it is 5. So we're going to multiply that by the negative 30 that we have over here. Okay, so then if we multiply that now, we'd get a negative 150. Okay, now let's continue. We have this. Let's look at our other terms. Do you see any other like terms? Your answer should be yes. So we have this 18 square root of 5 and this 20 square root of 5. If you notice, they're both square roots. There's a square root and a square root. There's also and they're both square roots of 5. So we can combine those. So combine the numbers. Combining, I'm meaning adding. On the outside, so we get 18 plus 20, which is 38 square root of 5. And we have this negative 12. Are we finished? The right answer should be no. We still have this number and this number hanging out. So negative 12 and a negative 150 turns into negative 162. And that is not a like term with 38 square root of 5, so we're just going to bring that guy down for the ride. And then our final answer is that negative 162. Negative 162 plus 38 square root of 5. All right, so let's continue with number 5. We have 2 more to go, and then we'll be good. And then you'll get lots and lots and lots of practice in class tomorrow. All right, so we have a fraction under a radical. But be careful, this 5 on the outside is just being multiplied by the radical. Okay, so it's not the index. The index has to be inside that little nook, but this one's outside the little nook. So it's not the index, it's just a 5 on the outside. So if you look on the inside, this part is just a fraction. So you can treat it just like any other fraction. So with fractions, you can simplify it first. So let's do that. So we have 5, and then we have the square root of 144x over 9. Well, 144 and 9 have something in common. You can take out a 9. So if we take out a 9 out of 144, so like we divide out a 9, we should get you should get a 16. And then you take out a 9 out of 9, like a 9 divided by 9, and you get 1. So if we rewrite that again, we have 5 square root of 16x over 1, which we can rewrite as 5 times the square root of 16x. Remember, 16x divided by 1, anything divided by 1 is just itself. Now, we can also break this up into 5 square root of 16 times the square root of x. Since 16 and x are being multiplied, if you're multiplying or dividing, you can split those up. So you can split up the radical between those two things that are being multiplied or divided. And we have 5, and then square root of 16 is just 4. And then square root of x, there aren't enough x's to pull out, so we'll just bring it along. And then our final answer is 20, which is the 5 times the 4 square root of x. All right, so one more to go. How are you feeling? I hope you're feeling okay. We just have one more, and then we'll be grand. So, all right, just like if you remember back in video 2, if we had something like square root of 4 over 3, we could split up the radical because 4 and 3 are being divided. And this can only happen if we're dividing or multiplying. Then you can split up the radical as a square root of 4 over square root of 3. Now similarly, you can go backwards. So in this one, we have 2 separate cube roots, but we can mush them together, and we can put everything that's under them under the same radical. So we have this 4 and this 2, and then we can make one big cube root, and we have inside we can do 27x squared over 9x. Remember, we can only do this because they're both cube roots. If the index is not the same, we could not do this. So then remember, the inside is a fraction, so we can simplify that just like anything else. So let's simplify this guy. All right, 27 and 9, what do they have in common? Well, they both have 9 in common. So if we take out a 9, we'll have 3. We take out a 9 down here, we'll have 1. Oh, hey, look, we have an x squared and an x. Remember, if you're dividing variables, the same variable, you subtract the exponents. We have a 1 down here. 2 minus 1. So we have a 3x in the numerator, and we have 1 in the denominator, and this is still a cube root. Now out here, 4 divided by 2. I think that can be simplified into 2. All right, and remember 3x divided by 1 is just 3x, so we end up with 2 cube root of 3x. Take a moment, think about it, decide whether that radical can be simplified anymore. Okay, well, the correct answer is no, because there's nothing else to pull out. That we can't group 3's into anything else, we can't group the x's into anything else, so they're just still in jail. So our final answer is 2 cube root of 3x. All right, well, that concludes video 2. Let's just conclude with the final summary, just to make sure we're all on the same page. So maybe just find some space on your page and then write this down. When you're adding and subtracting radicals, you can only add or subtract if what are the same? Only when the index and radicand are the same. Okay, so adding and subtracting, you can, adding and subtracting, you can only do that when the index and the radicand are the same. So remember, you simplify everything and then you add or subtract like terms. Like terms are only, radicals are considered like terms only if the index and the radicand are the same. And then you simplify, and then you're done. Now, multiplying and dividing, you can only do it, it's less specific, meaning that only one thing has to be the same, only the index has to be the same. Only the index has to be the same. And then remember, if you scroll up or look up on your paper, it has the steps. You multiply the terms that are on the outside, they stay outside. You multiply the terms that are on the inside of the radical, and they stay inside, and then you simplify everything, and then you're done. Okay, so that concludes video 3. I hope you had fun times. You'll have even more fun times tomorrow as you practice and travel from state to state. All right, have a good day.